Alright, so we are going to actually solve the same problem in terms of the pressure. So this one seems natural to me, easier for me to actually understand what's going on, but that doesn't mean that that calculation is going to be easier for this one. So let's just try to reiterate the problem. So it starts out with a 0.8 mole of this guy in 1 liter container, right? So you're given the number of mole and then you're given the volume, and also temperature is given, right? So let's just start out from that one. So pressure, we can actually use a PV equal nRT to actually solve this problem. The volume is actually given as 1 liter, right? And N start out with 0.08. Was that 0.08 or the 0.8? Ah, 0.8, okay. So that was 0.8 more. Then temperature, this has to be in Kelvin, right? So my memory just so bad. What was this thing? 22 degrees Celsius. So equal 22 plus 273.15. So I got a 295.15 K. And R, as you guess it, it's 0.082. So I can actually try to find the initial pressure, right? So the pressure is actually equal to nRT divided by V, right? So N times R times T divided by volume, right? So that's ATM for that one. And then I have a 0 mole of this one, right? So 0 times RT divided by V, which is also 0. So I'm just going to put the 0 here. And then the change of this one, I'm just going to put another small number here. The change is going to be, this is a pressure change, right? So pressure change is going to be this. This value is going to reduce, right? Because it's going to be forming the product. So this is going to be minus x. Oops, I should probably put equal minus x. And then I'm going to form two of these guys. So 2 multiplied by that one. Every time I lose 1, I'm going to make 2, right? Then the equilibrium pressure, this is pressure, right? Pressure is equal to, let me just, I don't like this. So let me just do the same marker with the same colors. Okay, good. So it's equal to this plus that, right? And then that one is also initial plus change, right? So it's that, right? Alright, then let's just calculate the Q here. Q is the same way. The product pressure squared, because I have 2 as a coefficient, divided by reactant, right? So this squared divided by that one, right? Which is this value right here. And this one right here is a Kp. And Kc is the one that we know, 0.0466, I believe. Or the 0.00466, I don't remember. 0.00466. That was, if you are not understanding this one, then it's e to the negative 3. The same number, 0.00466, right? And then the Kp and the Kc is related by this particular formulas. And that formula, I don't want to make a mistake here, so I'm just looking for the, let's see, how is that thing? there you go. So it's a Kc times RT. It's Kp is equal to Kc. Let me just write Kc times RT to the power of delta n. So that's the formula. The delta n stands for the number of mole of gas, changing number of mole of gas, right? So I have 1 mole of gas here, I have 2 mole of gas here. So the changing number of mole is actually 1 here, right? So the Kp is actually equal to Kc times RT to the power of 1, which is just RT. So Kp is actually equal to that one times R times T. So that's my Kp right here. Now I want to actually make this Q to become this guy, right? So let's just do that one. So go to the data tab, solver, and then I am going to make this Q to have a value of 0.113. I'm just reading off this value right here by changing that one. Did you follow? I wanna change this cell right here to go to the value of that value right here by changing that one, and then just solve it. Voila, it's already done. Then I have a final, this is a pressure, right? So now I'm going to convert this value to N. What is the number of mole? Because this is pressure, right? ATM. So if I use the PB equal nRT to solve for N, PB divided by RT, right? So let's just do that. Equal pressure times volume divided by parenthesis open R times T. Okay, I do the same thing for here. N is equal to pressure times volume divided by parenthesis open R times T. You see that one right here? That's the number of mole here. Oops. So number of mole, right? Now if you can actually try to convert this one to the molarity, the M, then this one right here is the number of mole in 1 liter. So it's also M, right? This is M and that's M. So I'm going to check whether I'm getting exactly the same number here. 0.77, 0.06. Let's see. 0.77, 0.6. This was the previous one using the Kc. This one right here is using the Kp here. So you are going to get exactly the same numbers. Why we are getting the same numbers? It's proved in the one of the attached sheet. So if you want to go ahead and take a look at it, you don't have to understand that one.